We're software developers, so it would seem natural for us to use software to make our job easier. That's really the fundamental idea behind the deployment pipeline. Our aim is to use automation in smart ways to make it easier for us to detect and so correct mistakes, and to more easily, more repeatably and reliably release changes into production as a result. There is more to it than that to get to these advantages though. There are some core ideas that are really fundamental to our ability to do this, but some of them are often missed. So what are 3 common reasons that your deployment pipeline isn't working as well as it should? That's our topic for today. Hi, I'm Dave Farley and welcome to the Modern Software Engineering channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content here today, hit like as well. I've been fortunate to be close to the birth of several ideas that became widely known and popular. And my impression is that the overwhelming response of the creators of these ideas is, that's not what I meant. This is semantic diffusion in action. As ideas become more widely spread, they become diluted. It's a bit like the whisper game that we played as children. As the message is passed around, it gets lost and mistranslated into something else. That has certainly happened with the idea of the deployment pipeline. And I can say this with a little bit more confidence, maybe a bit more authority than usual, because in this case, the deployment pipeline is a term that I made up, and so I know exactly what I meant. So let's try and squash a few misinterpretations before we go any further and define more clearly what this term actually means. The commonest misinterpretation seems to be that a deployment pipeline simply means your build script, an automated version of how you build your software, or that if you run a copy of Jenkins or similar tools, you have a deployment pipeline. Your build script is certainly a part of your deployment pipeline, and it certainly helps to have some kind of build management software to help you organize your pipelines. But neither one of these is on its own or even combined, even close to being enough to satisfy the definition and goals of a deployment pipeline. A core defining characteristic of a deployment pipeline is that it is definitive for the release of our software. That is, if our pipeline passes all of its tests, then we're safe to release our changes into production with no further work to do. We'll come back to that last part, no further work, later on, because that is the most common pipeline failure of all. A perhaps slightly more advanced mistake on the concept of a deployment pipeline is that it's a kind of workflow of automation steps that you use to carry out your build. This is a little bit closer to the truth, but still not really close enough. A good pipeline will certainly embody a workflow of steps, but it's much more than that. It's part of the process of releasing software. It's intended to give us clear, fast feedback. We want a clear, unambiguous message. This looks good, so you're free to move on. Or stop now, you've broken something, and we should be able to trust that message, whichever one it is. And that's the first big mistake. Using one of these more dilute definitions means that we miss something really vitally important in the properties of a deployment pipeline. What we want is for our feedback to be reliable and repeatable. For the same version of everything together, code, dependencies, configuration, host environment, language version, everything, then we get the same result every single time. Let me pause there to say thank you to our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Transfig, and Tuple. Equal Experts is a multinational consultancy built on applying the ideas and techniques that we talk about here to build great software for their clients. All of these companies, though, offer products and services that are very well aligned with the topics that we discuss here every week. So if you're looking for excellence in continuous delivery and software engineering in general, click on the links in the description below to check them out. If we want our results to be repeatable, then we need to take the idea of determinism in the scope of any and all tests seriously. That means that we need to control all of the variables that can change the results of those tests, and so that we can accurately reproduce any given state of our system that we're interested in, and so get those repeatable results. This has some serious implications for how we organize our work and how we design our systems. But the side effect is more determinism in design, and more determinism in tests too, both of which are very desirable properties to have. We need to apply techniques like infrastructure as code to ensure that our environments can be definitively version controlled and are, as a result, repeatably reproducible. We need to manage the versions of everything else so that a second run of the same build for the same software will always run exactly the same tests and give us exactly the same results. This means that within the scope of any single test, we must control the state of our system during the execution of that test. There are a variety of techniques that we can use to achieve that, but we must achieve it. Otherwise, our tests don't really mean very much. Sometimes it passes is simply not good enough for continuous delivery. So, for example, we need to take ideas like test isolation seriously too, to make sure that the execution of one test doesn't impact on the execution of any other. If you'd like to learn more about test isolation for more complex testing, check out my acceptance test-driven development course, From Stories to Executable Specifications, where we explore 3 distinct approaches to test isolation in some detail. If you'd like to learn more about how to build the kind of deployment pipelines that I'm talking about here are 3 ways that may help. You can buy my book, Continuous Delivery Pipelines, or you could try our introductory course, Get Going with Continuous Delivery Pipelines, or our more advanced course, Anatomy of a Deployment Pipeline. Check out the links for all of these things in the description below. Certainly, if we can't repeat our results, then we can't rely on them. But when I say reliable, I mean more than only that I get the same result every time. If I have one test that asserts that 1 + 1 = 2, then I can get that result every time. But that doesn't mean that I can reliably release my code if it does more than add 1 and 1. I have to also be testing stuff that matters to attain reliability. And we need to have enough of those tests to have confidence enough that if all my tests pass, then my system is very likely to work in production. So we need to achieve some predefined levels of confidence. For most systems of any complexity, I generally recommend dividing the pipeline into 3 phases: commit, acceptance, and production. My rule of thumb is to optimize my pipeline so that I have about 80% confidence that if all of my commit phase tests pass, then every other test in the pipeline will also pass. This idea encourages me to optimize for very fast feedback, that is, under 5 minutes, which means that I can find the most common kinds of failure and so gain valuable fast feedback very quickly, detecting and getting feedback on the vast majority of mistakes in that 5-minute period. The next phase, acceptance, is different. For this, we want to evaluate everything that determines the releasability of our system. So now we're really interested in that extra 20%. We're increasing our confidence in our release candidate. If we care about security, we need to test that. If we care about performance, we test that too. If we care about regulatory compliance, we automate testing for that as well. It's okay for the acceptance test phase to take more time though. After all, we are already catching the most common 80% of mistakes in commit. So the acceptance test phase is just building our confidence on top of that. We're much less likely to see a mistake here, so the trade-off between speed and accuracy changes between the commit and acceptance phases. I generally recommend that you aim to have feedback from the acceptance phase in under an hour. This is ideal, but to qualify for continuous delivery, you must have that feedback at least once per day. That is, we get a definitive statement on the releasability of our system at least once per day, however big, however complex. Remember, the point here is that if all of the tests pass in both commit and acceptance, then we're happy to release the change into production with no further work to do. So in this sense, reliability means good enough so that we can, in good conscience, release our changes into production without any further thought. The production phase is really our last resort. It's where we can observe our system in real-world use, and so learn things that we otherwise can't find out. We may find things that we missed, or learn things that we hadn't thought about, that will help us to improve our system in future. Or at a minimum, we can learn what our users like and what they don't like. If we've done a good job of the first 2 phases, this last phase, production, is not about finding bugs, though we may. But usually we'll have found most of the bugs already with our automated tests in commit and acceptance. Teams that practice continuous delivery and use deployment pipelines in the way that I recommend have very low bug counts in production, typically seeing huge drops. usually in the order of a couple of orders of magnitude fewer bugs, single digits instead of hundreds of bugs in production. For all of this to work, though, we need our pipeline to control every release into production, which brings us to our second common pipeline failure. That is, when the pipeline is not treated as the only route to production. This is a mistake because if we want repeatability and reliability, that's easiest to achieve if we establish a single way of doing things and we always practice that way. As soon as we allow more than one way to do things, the complexity explodes and we lose effective control. So by treating every change to production in the same way, whatever its nature, we can be more confident in the results that we get from the pipeline. And it makes our testing simpler overall. And as a result, the decision-making around release becomes simpler too. Whatever we change, the code, the infrastructure, an update to an operating system, anything, we run the same set of tests that tell us whether or not to release every time. If a single test fails, we reject the release. If all tests pass, then we're free to release with no more effort, no more thought really. I once consulted for a very large, rather bureaucratic firm building complex software. At some point in our discussions, someone said, "Oh, in an emergency, we'd do a Class 7 release, which we can do in under an hour." I jumped on that and said, "Okay, so why don't you do Class 7 releases all of the time?" They kind of giggled. Their answer would have been funny if it wasn't so sad, because we don't test anything in a Class 7 release, so it's too risky for normal releases. So at the point when disaster has struck and your system is collapsing around your ears, you pour petrol on the fire and release without testing anything. This is insane. I want to release the same way for a single line spelling correction to some text as I do for an emergency release when the critical services have failed. I want my deployment pipeline to be so efficient, so fast, that we can afford to run all of the tests even in that emergency case, because that's when we need their protection the most. Treat the pipeline as the only route to production for any change and always use it. I once worked on a team where the ops group hadn't really bought into the continuous delivery and DevOps ideas. We were in transition. The dev team had a very effective deployment pipeline and we'd automated everything. But the ops team were more old school and made changes to production by logging into servers and manually updating things, not trusting the automation really. This meant that new changes from development that were configured via automation as part of the creation of those changes using infrastructure as code were sometimes inadvertently subverted by ops people changing the configuration manually. So we had flakier releases than we really needed to. Always treat the deployment pipeline as the only route to production and make every change to production via version control. My final common failure in the use of deployment pipelines is when your pipeline is not treated as definitive for release, as I mentioned earlier. This mistake takes a variety of different forms though, but the most common one is also probably the biggest mistake of all. You can tell if you're making this mistake easily enough. If all of the tests in the pipeline pass, but there's still more work to do before you're confident to release, then you don't have a true functioning deployment pipeline because the deployment pipeline is definitive for release. The point here is at least as much about how adopting this approach makes us behave as it is about the automation itself. If we accept that the goal is to make the pipeline definitive for release, it removes any excuses that X is too difficult to test, or that this person must sign off the change, or that we must test with this other component or subsystem before we release the app into production. The goal of the deployment pipeline is to optimize all of these things and to optimize the decision-making as far as we can too. When we get this right and make the pipeline definitive for deployment, then it guides our choices, ruling out many bad answers and steering us in the direction of better answers to a lot of important questions, guiding us in the direction of much more effective, much higher quality development processes, continuous delivery. For example, there's a common assumption that some things are too difficult to test with automation, and so manual testing is a better response. That's a big mistake in my view. Manual testing is too slow, not as repeatable, and not as reliable, and actually lower quality overall than good automated testing. If something is difficult to test, don't assume that asking people to do it manually is a reasonable answer. Look at the problem again and try to figure out why it's difficult to test and fix that problem. Maybe with a bit more ingenuity, you may be able to find another way to test it. With enough ingenuity, you can test anything. I once saw a test rig for a system that was part of automatic teller machines that included a small collection of basic, essentially toy robot arms that inserted cards into the ATM to initiate transactions in support of their automated testing. To be honest, that's probably not what I would have chosen to do, but it certainly showed some lateral thinking and meant that the testing was continuous, repeatable, and automated. An alternative to something that drastic, though, that too few people use, is to use the idea of testability as a driver for software design and architecture. If something is difficult or impossible to test, it's always because the design is a problem. So fix the design to make the system more easily testable. This is one of the huge benefits of test-driven development, because in test-driven development, we drive design from testing. So you'd have to be doing a pretty poor job of TDD to build something that is difficult to test. As a simple example, if the software in the ATM was more modular, we could test the hardware mechanism that accepted the card separately, perhaps only during its design and development. And then, once that was working, trust it to work. Maybe verify it occasionally with some basic smoke tests as part of your pipeline, but don't build all test cases on the use of toy robot arms. Now, instead, we could initiate transactions by faking the use of real credit and debit cards in software only, meaning we could have many more tests and run them much more quickly. Initiating the software response by faking the inputs from the hardware, for example. A more modular design like this would make testing so much easier and faster that we'd be able to run a lot more test cases and so end up with better testing overall. Having been faced with the argument that we can't automate testing that so many times now and found ways around it every time so far, I'm now always skeptical when anyone says that something is untestable. If it's untestable, then that's a comment on its poor design or lack of creativity in the testers. So let's either think harder about how to test it or design it to be more easily testable. Poor testability is certainly a common problem, but the commonest problem of all is something else. And I think stems from the fear that you won't be able to scale your build and test enough to give you feedback quickly enough to operate continuous delivery. What many, maybe even most teams try to do for continuous delivery and assume is essential to it is to try too quickly, in my view, to decompose their software into smaller pieces and test those pieces independently of one another. The commonest form of this these days is probably to adopt a microservice style approach. But then these teams often get it wrong and end up instead with a bunch of too tightly coupled services that they only trust to release once they've tested them all together. This is not microservices, which by definition are meant to be independently deployable, allowing teams more autonomy. So the teams in this weird state end up with a distributed monolith rather than a microservice architecture, and that is slower and more complex to test than just treating it as a distributed monolith. And they abduct all of the advantages that we gain from continuous integration as a result, because they're not integrating until the software is supposedly ready for release once all of the components have been tested. The idea of continuous integration is that we integrate at least once per day. If you can't do that, then you're simply doing it wrong and losing the profound benefits that continuous integration has to offer as a result. The only real way to achieve pipelines that are definitive for release is to scope version control repos and pipelines to independently deployable units of software. That is, the correct scope of evaluation is software that you can comfortably release on its own without worrying about dependencies on other things. That doesn't mean that there aren't dependencies on other things, it just means that you've designed it in a way where you don't have to worry about those dependencies. Combined, the value of these three ideas may or may not be obvious, but these ideas are important because they impact on nearly everything else that we do. If you trust these ideas and stick to them, even when it seems difficult to do so, they'll apply a pressure on you that will guide your decision-making in some very nice directions indeed. They encourage us to increase determinism in our design and tests. This results in better, more reliable software systems. and tests that we can trust and rely on to support our ability to make changes to our systems more easily and more safely. They encourage us to control the variables, and certainly if you're anything like me, this leads us to design simpler, better, and once again, more reliable systems. By making our pipeline definitive for the release of our software, we're forced to think about automation more carefully and be guided to what we should automate and what we shouldn't. That is everything that determines releasability. In combination, these three ideas are a driving force for doing a better job. Thank you. Thank you very much for watching. And if you enjoy our stuff here on the Modern Software Engineering channel, please do consider supporting our work by joining our Patreon community. It's through their support that we're able to carry on making this content. And to our existing patrons, thanks once again for your ongoing support.